In this video, we're going to look at simultaneous linear equations. So all of the equations that you can see on screen at the moment are linear equations. And when a linear equation has two variables in it, as each of these do, in order to solve to get a value for either of those variables, you need two equations, so that we can see the relationship between the two variables on the examples on the left between x and y, or on the examples on the right between p and q. We can see those relations between each other across two such equations. And what will happen is when we solve these, we will get a value for x and a value for y that will satisfy the pair of equations. In other words, let's look at the examples on the left here. When we get a value for x and y, if we solve these out, if we put those values for x and y into either of the equations, what we get on the left of the equation will equal what is on the right of the equation. And let's just see how that would look. So for this example right here, on the left with x and y, let's just say that x is equal to 2 and y is equal to 5. So if we call the top equation equation 1 and the bottom one equation 2. So let's put our values that we've got here into equation 1 and see what happens. So instead of 5x, we're going to have 5 times 2. And instead of 2y, we're going to have 2 times 5. And that's going to be equal to 20. Which means we get 10 plus 10 equals 20. So we get 20 equals 20. Okay, so it satisfies equation 1, but will these solutions satisfy equation 2 as well? And we can check that out. So instead of 4x plus 3y, we're going to have 4 times 2 plus 3 times 5. And we're going to check to see if that's equal to 23. Well, 4 2s are 8, 3 5s are 15, and 8 plus 5 is 23. So you can see that in the situation here, the values that we have 2 and 5 satisfy both equations, and that is how we know that they are an actual solution to this pair of simultaneous equations. But you can get situations where a value for the variables will satisfy one of the equations but not both of them. So let's just take a look at that in our second example. So in equation 2 over here, we're going to check to see if the values p equals 0 and q equals minus 5 will work. So for equation 1 there, we're going to say p is 0, so we have 0, and then instead of minus 2q, we're going to have minus 2 times minus 5, and we're going to check to see if that's equal to 10. Well, minus 2 times minus 5 is 10, so we get 10 equals 10. So those solutions satisfy equation 1. Let's check if they satisfy equation 2 this time. So instead of 3p, we have 3 times 0. And instead of 5q, we've got 5 times minus 5. We're going to check to see if that equals minus 22. 3 zeros are 0, and 5 times minus 5 is minus 25. And minus 25 does not equal minus 22. So you can see that having a solution for one of the equations does not automatically mean that you have a solution for the pair of equations. So how do we go about solving these? How do we get to a point, if we're presented with equations like this, where we can say these are the values for our variables? Well, let's take a look at some examples. So there are 5 steps to getting this sorted out. The first thing we need to do is we need to make sure that both of the equations are written with the x and y to the left of the equation and some constant number to the other side, some number without a letter attached to the other. Now the general form that we write for that is ax plus by equals c, where a is just the coefficient of x, the number in front of x, b is just the coefficient of y, just the number in front of y, and c is just a constant. It's just a number without a letter attached. Now in our example over here, both of the equations are written like that, so we're good. So far so good. Now what you need to do is you need to make sure that the coefficients of either x or y match, but have opposite signs. So the coefficients are just the numbers that are in front of the letters, and I'm saying x or y, but obviously in other questions you could get a p or a q. So in this particular example here, the numbers in front of y already match and we have different signs. So we've hit our second point. So far so good. Next up, what you got to do is you've got to add together your equations to remove the variable with the matching coefficients. Now this is where it gets a little bit less obvious. So we're going to label these equation 1 and equation 2. It's going to rewrite these out. So we're going to have x plus y is equal to 7 and x minus y is equal to 1. So you write them lining up the x's, lining up the y's, lining up the equals, lining up the constants. And then you draw a line underneath like this. And we're going to add everything down. So x plus x, that's equal to 2x. Y minus y is equal to 0, so we don't need to write that. And 7 plus 1 is equal to 8. So now we have an equation with one variable. We have 2x is equal to 8. So from here what we can do is we can solve this to get a value for x. If 2x equals 8, then x is equal to 8 over 2. So x is equal to 4. Okay, so we've actually gone through two of the steps now for this. We added them down, cancelling out one of the variables. And the fourth step in solving this is we solve the resultant equation, which is us solving 2x equals 8 to get a value for x. The last step to get the value for the other variable is we take our value for x and we put it back into either of the equations. Now, we only need to put it into one of them and we should get our value for y out. So we'll take equation 1. Equation 1 is x plus y equals 7, but we know, having just figured it out, that x is equal to 4. So what we get is 4 plus y is equal to 7. So y is going to be equal to 7 minus 4. So y is going to be equal to 3. So those are our two values. X is 4 and y is 3. You might sometimes see these presented as 4, 3, like that. But don't worry about that. Just leaving it as x equals 4 and x equals 3 is a perfectly fine solution. Now just as a little aside, just to prove for certain that this is definitely a solution to both of them, we've shown that this is a solution for equation 1, but we can check that it works for equation 2. We don't have to, but we're just going to check. So equation 2 is x minus y equals 1. We have a solution of x equals 4 and y equals 3. And 4 minus 3 is 1. So we can say for certain this satisfies both equations. But this example was a very easy example. This one was very straightforward and we didn't have to do too much messing about with that. Let's take a look at what we do when we have a more complicated example. So say something like this. So first thing we got to do is we got to make sure to write our equation in the form ax plus by equals c. Both of our equations are done like that. That's good. Now we need to make the coefficients of either x or y match, but with opposite signs. And we are nearly there. So in this one, our equation 1 is 2x plus y equals 14. And our equation 2 is x plus y equals 9. Now you notice that the coefficients of y match in this case, but they don't have different signs. So what we're going to need to do for this is we're going to need to change the signs on one of the equations. So what we're going to do is we're going to change the signs on equation 2. Equation 1 won't change. It stays as 2x plus y equals 14. But equation 2, what we're going to do is we're going to multiply everything in equation 2, every single term, by minus 1. So x times minus 1 is minus x, y times minus 1 is minus y, and 9 times minus 1 is minus 9. We multiply them all. If we only multiplied the y, in other words, if we only changed the sign on y, then we would have changed the value of the equation and we won't get a solution that will actually work for both equations. So now that we've got them matching, which we got the coefficients matching but with different signs, we can go to the next step, which is to remove the variable with the matching coefficients by adding things down. So 2x minus x is x, y minus y is 0, and 14 minus 9 is 5. So we have our value straight away for x. Nice and straightforward. And we can get our value for y by taking this value for x and putting it back into either of the first equations. So in practice, it's best to just pick the one that requires the less work. So we'll take equation 2 in this case. So instead of x plus y, we're going to have 5 plus y. And that's going to be equal to 9. So we're going to be able to say that y is equal to 9 minus 5. So y is equal to 4. So we have our value for x, which is 5, and our value for y, which is 4. So that's our solution for that one. But let's step it up again. Let's make this a bit more complicated with our next example. So in this example, if we're trying to solve these out, you'll notice that none of the numbers match up at all. There's nothing can be done there for to start with. We can't just start off right away and get this done. We're going to have to do something in order to make these match. So what we're going to do is, we're going to go to our steps. Are the equations written in the form ax plus by equals c? Yes. X, y equals constant. Perfect. All set up. Now we've got to make the coefficients of x or y match, but have different signs. So what we're going to do is, because the y's already have different signs, we're going to do something to make the numbers match. And there's a very simple trick to this. If we want the y's to match, we're going to multiply equation 1 by the coefficient of y from equation 2. And we're going to multiply equation 2 by the coefficient of y from equation 1. And that might sound like a lot, but let's just see what that means. So equation 1 gets multiplied by 3, and equation 2 gets multiplied by 2. Because we want the y's to match, they get multiplied by the number in front of the other y. So equation 1 times 3 becomes 9x plus 6y is equal to 39. And equation 2 times 2 becomes 8x minus 6y equals 12, like that. Okay, so now we have the coefficients for y matching up. This is going to work out well for us, and we're just going to sort this out from here. So 8x, or 9x plus 8x is going to be 17x, and then 6y minus 6y is 0, and 13 plus 12 is going to be equal to 51. So now we have 17x equals 51. And we can solve for x by saying x is equal to 51 over 17, which means x is equal to 3. So now we have our value for x. So what we're going to do is we're going to take our value for x and put it back into either of the starting equations. Might be easier to choose equation 1 this time. So instead of 3x plus 2y, we have 3 times 3 plus 2y, and that's still equal to 13. So 9 plus 2y is equal to 13, which means 2y is equal to 13 minus 9. I'm sorry, I've run out of space. Let's move up here. Which means that 2y is equal to 4. So y is equal to 4 over 2. So y is just equal to 2. So those are our values for x and for y in this pair of simultaneous equations. Now I guess that is that for this video.